Welcome back to the next lesson on chapter 8, which is rates in equilibrium. You know, we're just concentrating on the rates section for now. So this topic on rates is about how we can make reactions faster, and the underlying principle is based on the collision theory. So we've talked about, just as a recap, we said reactions occur when particles collide with enough energy. And here's this picture that I know that you love. We've got that red and blue particle there colliding. It looks like they've got plenty of energy. They are going to react. Now, so this topic is about how we can make reactions faster. So if we want to make the reaction faster, we're going to have more collisions, more frequent collisions, or we're going to have collisions that have more energy. In the first lesson, we talked about how we could change the surface area. If we changed the surface area to volume ratio, well, if we increased the surface area to volume ratio, do you remember we said there'd be more particles exposed, so there will be more frequent successful collisions. So if we have a solid, we can crush it up, increase its surface area to volume ratio, and that will make the reaction faster. Today we're going to look at liquids and gases and how we can increase the rate of the reaction of liquids and gases. So if we want to get some file paper, and let's get started. So today we're looking at concentration and pressure. We are going to explain the effect of concentration and pressure on the rate of a reaction. Okay, so when we're talking about concentration, we tend to be talking about liquids and solutions. If we're talking about pressure, we're talking about gases. But the underlying principle of how we can change the concentration and pressure is the same. First of all, first question, how would you lower the concentration of a solution? How would you lower the concentration of a solution? That's right, we would dilute it with water. So if something has a lower concentration, it tends to be being diluted with water. So if you think about orange squash, a low concentration of orange squash would have lots of water in a certain volume, where a higher concentration would have more orange and less water. Okay. Now, before I even teach you anything, or before we go through this, you probably understand that if something has a higher concentration, what would that do to its rate of reaction? The higher the concentration, the faster the rate of a reaction. So I've got two diagrams here, I think they're worth copying down. One of a low concentration, one of a higher concentration. Let's imagine that the red particles are acid particles and they're reacting with this solid in the middle. Now, why would the one on the right, why would the one with a higher concentration react faster? The first thing you would spot, obviously, is that there are more particles. But just saying more particles wouldn't be enough, because having more particles, just that sentence doesn't take into account how big the volume of liquid we've got. Okay? So we have to say the higher concentration, there are more particles in a given volume. So what? What would be a consequence of there being more particles in a given volume? Why would that make the reaction faster? And here's that sentence again. There will be more frequent successful collisions. So if we have a higher concentration of a liquid, there are more particles in a given volume, there are more frequent successful collisions, so the reaction will be faster. The pressure works in a very similar way. The higher the pressure, the faster the rate of a reaction. So on the left, we've got a picture with low pressure. Our red particles are now gas particles. On the right, we have a higher pressure. If we have a gas at a higher pressure, why would it react faster? What's a logical thing to say? Yep, there are more particles in a given volume. If With a higher pressure, there are more particles in a given volume. So what? Always think about so what. What does that sentence mean? What does that lead us to? If there are more particles in a given volume, there are more frequent successful collisions. Exactly the same as when we were talking about concentration. If we have a higher pressure, it's going to be a faster rate of reaction. Higher concentration, a faster rate of reaction. Why? There are more particles in a given volume, so there are more frequent successful collisions. Now, that might seem straightforward. Hopefully it does, because it's quite a simple principle. We've got to make sure we get the wording right when we're answering a question. We have to understand that if we increase the concentration or the pressure, there are more particles in a given volume, so there are more frequent successful collisions. Now, as an extra task you may want to do, you could plot a graph. This is an experiment where we've had magnesium reacting with acid. We've collected the volume of gas given off. You may want to plot the graph. This shows the reaction with two different concentrations of acid. 0.5 mole per decimeter cubed acid, and we did it again with 1 mole per decimeter cubed of acid. So if you're at school, this is the kind of experiment you might want to do. You could plot these results on the same graph, and I will send you some extra questions that you can work through on those. Okay? As always, any questions, ask your own teacher. We've now covered surface area, how it affects the rate of reaction. We've covered concentration and pressure, how they affect the rate of reaction. Hope that makes sense. Thanks very much. Goodbye for now.